Hello students, welcome to ePhysics. Students, in this video we will be discussing about the graphical representation of motion. So let's start it. Students, in graphical representation of motion, we will start to learn how we can represent the motion of anything, any object in graph. Okay, and what type of graph represents what, and suppose we are supposed to be finding velocity, acceleration, distance, then how will be finding the things with the help of graph that we will be learning now. So the first thing that we will discuss here is the distance time graph. Okay, the distance time graph. Now, students, distance time graph in short can be written as xt graph. Okay, where the x represents, where this x means change in position, that is the position of course, and this t means time. Okay, now let's start it. Students, let us suppose we have a coordinate x-axis and y-axis. We know the horizontal axis is known as x-axis, the vertical axis is known as y-axis. Suppose we consider this vertical axis as a distance graph, that is x, okay, and the horizontal axis as the time axis, let us consider t, and this is where the point intersects, is the point of origin. Okay, now student, if the graph of the motion obtained in xt graph is a straight line, okay, if it is a straight line from the origin of course, okay, if it is a straight line, then what does it represent? Students, it gives us the speed. Okay, distance and time graph gives us the speed, or we can also consider as velocity if it is displacement time graph. Okay, now what kind of speed is this? This slope of xt graph is a linear slope. Okay, linear slope, or we can say it is a straight line. So a straight line represents uniform motion. It represents uniform motion. And how will be finding the speed of it? Now students, this point, this final point is at, let us consider it is at A, and in time axis let us consider it is at B. Okay, now from the formula that we have studied earlier, that speed is equals to distance upon time. Okay, speed is equals to distance per unit time. Here students, what is the distance here? The distance is OA, because the vertical axis is representing the distance. Okay, therefore the distance traveled is OA divided by time. Time, we have considered the horizontal axis as the time axis, and the time to travel, time taken to move from O to A is O to B. Therefore, time travel is OB. Is it clear, students? So this is how we used to find, or we used to represent the motion of the object in distance time graph. And this, if we are getting a linear or a straight line, then we say that the motion is uniform. That is uniform motion, or we can simply say it is uniform speed. Okay, so since we are finding the speed, it is uniform speed. Now students, here the slope says that it is uniform speed. Uniform speed means the velocity is not changing. Okay, the velocity is constant. Now, if the velocity is constant, that is the velocity is not changing. Okay, if the velocity is not changing, then what kind of motion is this? Here we can say the acceleration of the object in this particular case is equals to 0. because acceleration is equals to change in velocity, and here the velocity change in velocity is 0. If the change in velocity is 0, therefore we can simply say the acceleration is also 0. Now this is the case of uniform speed, that is a straight line slope we have obtained in xt graph. Now what about the non-uniform speed or the non-uniform motion? We will see that now. Now senior students, let us consider the same graph. Okay, the same graph, the horizontal axis denotes the time and the vertical axis denotes the distance or the position. Okay, now, and this point of intersection, let us consider this is O, the point of origin. Now let us consider we get a parabola shaped slope. This is a curved line, of course. This is curved line, that is parabolic in shape. Okay, parabolic in shape. And here we have seen that at any point of time it was linear, but suddenly the change in the position with respect to time is not constant, that it is changing. Okay, it is changing, and it is not changing uniformly, and that is why we have got a curved slope. Okay, we have got a curve over here, and this curve is generally parabolic in nature, or it may be of any curved shape. So this kind of speed or this kind of slope represents non-uniform speed. Okay, it represents non-uniform speed. Now here students, we can say here, since the position is changing and the velocity here is not constant. Okay, velocity is not constant, that at every interval of time the change in velocity, we are getting any value for the change in velocity. And according to the definition of acceleration, we know that change in velocity is known as acceleration. Therefore here in this case the object is in accelerated motion. Okay, here the object is in accelerated motion. Okay, so this is about distance time graph. Now we have studied about uniform speed. There we have got a straight line, straight slope or a linear slope, and here we have got a curved slope. Generally we represent the curved slope with a parabolic shape slope. So here and here in this case the speed is non-uniform, there it was uniform speed. Okay, now let's move to the speed time graph. Now the second type of representation of motion is speed time graph. Speed time graph is also known as velocity time graph, and in short form we can also write it as VT graph. Okay, now let us consider students, again we have a coordinate system. Okay, we have a coordinate system. Let us consider this, the point of origin is O, this is the time axis, the horizontal axis, and let us consider the vertical axis is representing the velocity of the object. So students, here let us consider the first case in the graphical representation of motion in a VT graph. Let us consider the velocity of the object is constant at every interval of time. Constant means at every interval of time, let us consider it is 10 meter per second. At the 5 minutes later it is again 10 meter per second. 10 minutes later it is again 10 meter per second. At every interval of time you will see that the velocity of the object is 10 meter per second. So the graph so obtained, the slope so obtained is parallel to the time axis here. Okay, this slope is parallel to the time axis, and here the velocity is constant. Velocity is constant. Okay, now here students, if the velocity is constant, then we can simply say that here in this case the acceleration of the object is 0. Okay, so these are the three things that we have studied. Now what do we get from a VT graph? Students, we can find from VT graph, can find distance. How distance? We know the formula of distance. Distance is equals to speed multiplied by time. Okay. Now this speed is represented from the vertical axis. Let us consider it is let us name it. Okay. Now let us consider this is A, and let us consider this point as B. Okay. Now velocity is b meter per second, that is OB meter per second, OB meter per second multiplied by time. Time is OA seconds. OA seconds. There second and second gets cancelled. So we are left with OB multiplied by OA meters. Okay. Now here we can say the distance is equals to OA multiplied by OB. And the unit of distance is of course meter. And here students, one more thing that we have got, that OB is in this shape. You can see this is a rectangular in shape. Okay, this shape is rectangular. OB, let us consider this is C. OBCA is rectangular. Okay, so here we can see that OB multiplied by OA, that is the length multiplied by breadth, is equals to area of rectangle OBCA. So students, in speed time, that is velocity time, or VT graph, we can find the distance of the object, distance traveled by the object is equal to area enclosed between the velocity time slope and the time axis. Okay, this is the time axis and this is the velocity time graph, velocity time slope. So area between the time axis and the velocity, and the area between the velocity time slope and the time axis is known as distance traveled. So this is how we find the distance traveled in velocity time graph. Okay, this will be applicable in any case, whether the slope is a straight slanted line, whether the slope is a curved line, or anything. Here we have seen the first case. In this case we have considered the velocity is constant, acceleration is 0, and this is the first thing that we were supposed to be studying. That is why we have taken it. So let's move to the other part now. Now students, in the other case of the speed time, velocity time, or the VT graph, let us consider this is the coordinate, this is the origin, this is the time axis, the horizontal axis, this is the velocity axis, that is the vertical axis. Let us consider students, from the motion of the object we have got a straight line. Okay, a straight line from the origin. Now since it is a straight line, we have studied students in the first graphical representation that if we get a straight line that represents a uniform motion, therefore here it is representing uniform acceleration. Why uniform acceleration? Because the velocity is changing uniformly at equal interval of time. Okay, so here the velocity must be 2 meter per second, here the velocity must be 4 meter per second, here the velocity must be 6 meter per second after every equal interval of time. Let us consider this is 2 seconds, this is 4 seconds, this is 6 seconds. Okay, let us consider this. This is just an example, we can consider it. So the velocity is changing uniformly at equal interval of time. Therefore the motion of the object according to the slope is uniform acceleration. Okay, uniform, this is uniform acceleration. Okay, this is uniform acceleration. Okay, now here how will we find the acceleration? Here acceleration is equals to change in velocity divided by time. So the velocity is equal to, let us consider this is A and let us consider this is B. So change in velocity, that is O to A divided by time taken, that is O to B. Okay, so this is acceleration we have got. Now from VT graph we have studied that from VT graph we get the distance. So we will be finding the distance as well. and distance is found by the area enclosed between the slope of VT graph and the time axis. Here, this area so formed is triangular in shape. This O, let us consider this is C, O, C, B. So we can find the distance is equals to area of triangle O, C, B, which is equals to 1 by 2 into base. Base is equals to OB multiplied by time. Time is equals to BC, or you can also write OA. Okay, this is OA. So this is how we were supposed to find the, distance also. So we have got the acceleration from this, and we have got the distance as well from this. Now this is the case of acceleration. What if the object is slowing down and that be studied as negative acceleration or deceleration or retardation? All the things are same. Let's see the graph of that. Okay. Now students, in the case of retardation, let's see this. Again, the horizontal axis representing the time, the vertical axis representing the velocity. Let us consider the initial velocity of the object is somewhere around here, and slowly it is getting down, it is slowing down, and it comes to 0 at any point of time. Let us consider this is O, this is A, and this is B. Clear? Now, how will be finding the distance over here? Distance, of course, the area enclosed between the slope of the VT graph and the time axis, that is this one, and this area is again triangular in shape. Therefore, distance will be equal to area of triangle. What is the triangle? Let us name it as OAB. So this is OAB. We know the formula of area of triangle, that is 1 by 2 into base into height, that is OB multiplied by OA. Okay, so this is uniform retardation. Uniform retardation. Clear? So this is the third case. Now let's move to the fourth case. Okay. Now here students, we will be representing the VT graph, and in VT graph we will be seeing, in this case, the initial velocity of the object is not 0. Okay, it is not 0. So it is representing the velocity axis, the vertical one, the horizontal axis representing the time. Now if it is not 0, it must be somewhere around here. Let us consider this is A4, initial velocity is A, and afterwards let us consider it is having a uniform motion or uniform velocity, that is uniform accelerated motion from there, from O. Now how will we find the distance in this case? So we can draw it, we can connect it, okay, and let's name all the points. Let us consider this is B, this is C, this is D, this is E. Okay, here students, in this case we can see a trapezium, that is OA, C, and this DE. Okay, this is a trapezium so formed. So distance traveled is equals to area of trapezium, that is OACE, or we can see this is a triangle and this is a rectangle. So this can also be written as area of triangle ADC plus area of rectangle. Area of rectangle, that is AOED. AOED. Now here in both these cases, let's see the values first. Area of trapezium is equals to 1 by 2 into sum of parallel sides, that is OA multiplied by CE. OA plus CE multiplied by the distance between them, and the distance between them is OE. Okay, this is OE. So this is the case of trapezium. Now let's see the second one. Area of triangle is equals to 1 by 2 into base into height. Base is equals to AD. AD can be written as OE. So this is OE into height. Height is equals to nothing other than CD. So this is CD. D plus area of rectangle. Area of rectangle is equals to OA multiplied by the length, that is OE. This is OE. So students, here if we take OE common, we can find the value over here. So this is how we used to find the things. In this case, we can find the distance by two ways. That is, one, the shape formed is the area of trapezium OACE, and the other, we can find the distance from adding the two shapes, that is area of triangle ADC and area of rectangle AOED. So this is how we represent the uniform accelerated motions in VT graph. Now let's move to the non-uniform accelerated motion in the VT graph. Now students, non-uniform accelerated motion. Let us consider this is T, this is V, okay, and the slope so obtained is this one. This is a curve, okay. So this here in this case the velocity is not changing uniformly, therefore this is non-uniform acceleration, okay. This is non-uniform acceleration. So students, how will you find the distance in this case? So this, you have to find the area of this part, okay. Now here we are not having a proper line slope or a linear slope, that therefore from simple mathematics we cannot find it. You will be studying in the next video. I will be teaching you how to find the area of this part, okay. So this video is from the class 9th perspective, that is why we are not going that deep. We will be discussing to find how to find the area of this part so that we can find the distance. In this case, we will discuss it later on in the next video. I hope you understood the things very nicely. Thank you very much for watching the video.